Hello my dear children, welcome to the mathematics class. Today we are going to discuss the chapter continuity and differentiability. We continue the same chapter and exercise 5.7. Exercise 5.7, page number 183. Page number 183. Yesterday we have discussed in this exercise till the question number 10. Isn't it or not, my dear children? Yes. Now come to the question number 11. Question number 11. If y is equal to 5 cos x minus 3 sin x, prove that d square y by dx square plus y is equal to 0. Understood the question, my dear children? Here a function is given. We have to prove this statement. To prove this statement, what are the values to be found? D square y by dx square. We have to find d square y by dx square. Okay, my dear children. Then we substitute in this equation d square y by dx square plus y. Then we get RHS value. Okay, my dear children. Right. Come to the solution part. Given y is equal to 5 cos x minus 3 sin x. I wrote the given function here. Okay, my dear children. Right. Differentiating with respect to x. What is the differential operator here? X. Because the function y is defined in the variable x. So we are differentiating with respect to x. Okay, my dear children. So I wrote the differential operator on both sides. D by dx of y is equal to d by dx of 5 cos x minus 3 sin x. Understood this step, my dear children? Right. This implies dy by dx. What will you get in LHS? D by dx of y. What is the value of d by dx of y? dy by dx is equal to, come to the RHS part. If you observe this function, it has two terms. It is defined as the sum of two terms. 5 cos x is the first term, minus 3 sin x is the second term. So we differentiate this function by taking the differentiations of these two terms separately. So d by dx of 5 cos x minus, we are taking the differentiation of the second term, d by dx of 3 sin x. Understood this step, my dear children? Right. I wrote here because d by dx of y is equal to dy by dx. In LHS, we used this result. Understood this step, my dear children? Right. This implies I wrote LHS as it is, dy by dx is equal to, if you observe this first term, d by dx of 5 cos x is there. In this part, 5 is the numerical coefficient. So we write it before the differential operator. So I wrote 5 before the differential operator dy by dx. Okay, my dear children? Then what is the function left here? Cos x. So we write d by dx of cos x. Understood this first term, my dear children? Right. Similarly, come to the second term, minus, here 3 is the numerical coefficient. So we write this 3 before the differential operator. 3 into d by dx of, what is the function left here? Sin x. Understood this second term, my dear children? Right. This implies I wrote LHS as it is, dy by dx is equal to 5 into d by dx of cos x. What is the value of d by dx of cos x? Minus sin x. Do you remember this formula, my dear children? Right. Minus 3 into d by dx of sin x. What is the value of d by dx of sin x? Cos x. Do you remember this formula, my dear children? D by dx of sin x is equal to cos x. Understood this part, my dear children? Right. I wrote the formulas also. Because d by dx of cos x is equal to minus sin x and d by dx of sin x is equal to cos x. I used these two formula to get this step. Understood this step, my dear children? Right. This implies dy by dx is equal to minus 5 sin x minus 3 cos x. Okay, my dear children, right. We have found here dy by dx value. Okay, my dear children, we again differentiating with respect to x because we have to find d square y by dx square. That is why again we are differentiating with respect to x. Then what is the differential operator? Yes, d by dx. So I wrote the differential operator d by dx on both sides. So this implies d by dx of dy by dx is equal to d by dx of minus 5 sin x minus 5 sin x minus d by dx of 3 cos x. I wrote directly and separately. Understood this step, my children? RHS part. Right. This implies what is the value of d by dx of dy by dx? Yes, d square y by dx square. Remember this notation, my children. D by dx of dy by dx is written as d square y by dx square. Okay, my dear children, right. That is equal to, here minus 5 is a numerical coefficient. We write it before the differential operator. So I wrote before the differential operator. Then d by dx of, what is the function left here? Sin x. So d by dx of sin x. Understood this part, my dear children? Right. Now come to the second term. Minus, here also 3 is a numerical coefficient. We can write it before the differential operator. So I write here 3 into d by dx of, what is the function left here? Cos x. Understood this second term, my dear children? Right. In this step, I used this result, d by dx of dy by dx is equal to d square y by dx square. By using this result, I wrote this step. Understood this step, my dear children? Right. This implies d square y by dx square. I wrote LHS as it is equal to minus 5 into, come to the first term, minus 5 into d by dx of sin x. This is a standard function, derivatives of standard functions, you know that. So d by dx of sin x is equal to cos x. Understood this first term, my dear children? Right. Minus 3 into, come to this part, d by dx of cos x. What is the value of d by dx of cos x? Right, minus sin x. Do you remember this formula, my dear children? This is also standard function. So minus sin x. Understood this second term, my dear children? Right, because d by dx of sin x is equal to cos x and d by dx of cos x is equal to minus sin x. By using these two formulae, I wrote this step. Understood this step, my dear children? Right. This implies d square y by dx square is equal to minus 5 into cos x. What will you get here? Minus 5 cos x. Minus into minus. What will you get here? Sin plus 3 sin x. 3 into sin x, 3 sin x. Understood this step, my dear children? Right. This implies, I wrote LHS part as it is, d square y by dx square is equal to, from these two terms I am taking minus common. We are taking minus common factor. So what will you get in the brackets? 5 cos x minus 3 sin x. Understood this step, my dear children? Right. This implies d square y by dx square is equal to, in RHS we can write minus y because y is equal to 5 cos x minus 3 sin x. This is a given function. Okay, my dear children, understood this step? Right. This implies now we are bringing this minus y to LHS. Then it becomes plus y. Okay, my dear children? So d square y by dx square plus y is equal to 0. This is a required statement to be proved. Isn't it, my dear children, or not? Right. Hence proved. Understood, my dear children? Right. Now page number 184. Page number 184. Question number 12. Question number 12. If y is equal to cos inverse x. So y is equal to cos inverse x. Find d square y by dx square in terms of y. Understood this question, my dear children? We have to find d square y by dx square in terms of y, not in terms of x. Okay, my dear children, understood? Right. come to the solution part. Given y is equal to cos inverse x. I wrote the given function as it is here. Okay, my children. Right. This implies x is equal to cos y. From the inverse trigonometric functions, we can write this equation. Isn't it or not, my children? Understood this step, my children? Right. Now, if you observe this function, this x, the variable x is defined in the variable y. So, we are differentiating with respect to y because the function x is defined in the variable y. Understood this step, my children? Differentiating with respect to y. Not we are differentiating with respect to x. Okay, my children? Right. This implies what is the differential operator then? Yes, d by dy. So, d by dy of x is equal to d by dy of cos y. I wrote the differential operator d by dy on both sides. Understood this step, my children? Right. This implies d by dy of x. What is the value of d by dy of x? Yes, dx by dy. Understood LHS part, my children? Right. That is equal to d by dy of cos y. This is the standard formula. D by dy of cos y is in the form of d by dx of cos x. What is the value of d by dx of cos x? Right, minus sin x. So, minus sin y because variable is y. So, minus sin y. Understood this RHS part, my children? Right. Because d by dy of x is equal to dx by dy and d by dx of cos x is equal to minus sin x. We are using these two results to get this step. Understood this step, my children? Right. This implies dy by dx is equal to, here in LHS dx by dy is there. So we are finding dy by dx. Dy by dx is equal to 1 by minus sin y because dy by dx is equal to 1 by dx by dy. Okay, my children, understood this one? Dy by dx is equal to 1 by dx by dy. We take its reciprocal. Okay, my children? Right. This implies I wrote LHS as it is dy by dx is equal to 1 by sin y. What is 1 by sin y value? Cosecant y. So, minus cosecant y. Understood this RHS part, my children? Because 1 by sin y is equal to cosecant y. By using this result, I wrote this term. Understood, my children? Right. We have found dy by dx. Now we are going to find d square y by dx square. That is why we are differentiating with respect to x. Observe this sentence, my children. We are not differentiating with respect to y. Here we are differentiating with respect to x only. Understood this step, my children? Right. Then what is the differential operator? Yes, d by dx. So I wrote the differential operator d by dx on both sides. So this implies d by dx of dy by dx is equal to d by dx of minus cosecant y. Understood this step, my children? Right. This implies, come to LHS part, what is there? D by dx of dy by dx. What is the value of d by dx of dy by dx? Yes, d square y by dx square is equal to, here already minus is there, d by dx of cosecant y. It is not a standard formula. We have to use chain rule. Okay, my children. So d by dx of cosecant x. What is the formula? Minus cosecant x into cot x. Already minus is there. So we are not writing any sign here. Minus of minus, we get a positive sign here. Cosecant y, cot y. Understood this part, my children? Into d by dx of y. Because we are using here chain rule, because this function is not in the standard form. Understood this step, my children? Right. Because d by dx of dy by dx is equal to d square y by dx square and d by dx of cosecant x is equal to minus cosecant x into cot x, and also we used chain rule to get this step. Understood this step, my children? Right. This implies we wrote LHS as d square y by dx square is equal to minus cosecant y into cot y. I wrote this part also as it is, into d by dx of y. What will you get? Dy by dx. What is the value of dy by dx? Minus cosecant y. Minus cosecant, I don't write here directly, dy by dx value. Minus cosecant y. Here we get dy by dx. D by dx of y is equal to dy by dx. Understood this statement, children? Right. This implies, come to LHS part, we wrote as it is d square y by dx square is equal to cosecant y into cot y into dy by dx. What is the value of dy by dx? Minus cosecant y. We have already found, because dy by dx is equal to minus cosecant y. Understood this statement, children? Right. This implies d square y by dx square is equal to, what is the sign we get here finally? Minus. Understood this part, my children? Right. Cosecant y into cosecant y. What will you get here? Cosecant square y into cot y. Understood this part, my children? Right. This is the value of d square y by dx square in terms of y. Observe here. What is the variable here? Y only. There is no x. So we have found the value of d square y by dx square in terms of y only, not in terms of x. Understood, my children? Right. Now come to the question number 13. Question number 13. If y is equal to 3 cos of log x plus 4 sin of log x, show that x square y2 plus x y1 plus y is equal to 0. Understood this question, my dear children? Here the function y is defined like this, and we have to show this statement. To show this statement, what should be found? y2. y2 is nothing but d square y by dx square. y1 denotes dy by dx. Okay, my dear children? So before going to prove this statement, we have to find dy by dx as well as d square y by dx square. Okay, my dear children? Right. Come to the solution part. Given y is equal to 3 cos of log x plus 4 sin of log x. Consider this function is 1. Let us consider this equation as first equation. Now we are differentiating with respect to x. We are differentiating with respect to x. Then what is the differential operator? Yes, d by dx. So I wrote the differential operator d by dx on both sides. So this implies d by dx of y is equal to d by dx of 3 cos of log x plus 4 sin of log x. Understood this step, my dear children? Right. This implies what you get d by dx of y. What is the value of d by dx of y? Yes, dy by dx. Understood this LHS part, my dear children? Right. Is equal to, here 3 is numerical coefficient. I wrote it outside. Then we take the next function d by dx of cos of log x plus, similarly here 4 is a numerical coefficient. I wrote it before the differential operator, and we wrote d by dx of function sin of log x. Understood this step, my children? Right. This implies in LHS I wrote dy by dx as it is equal to 3 into, observe this first term, it is in the form of d by dx of cos x. You have to assume this log x as x in your mind. So d by dx of cos x, what is the formula? Minus sin x. So minus sin of log x. Understood this part, my children? Into d by dx of log x, because we assumed log x as x in our mind. So we have to differentiate that function. Whatever we assumed as x in our mind, we have to differentiate that function here. Understood this part, my children? Right. Plus 4 into, observe this function, it is in the form of d by dx of sin x. Assume this log x as x in your mind. So it is in the form of d by dx of sin x. What is the formula? D by dx of sin x? Yes, cos x. So cos of log x. X means we assumed here log x as x in our mind. So cos of log x into d by dx of log x, because we have to differentiate this log x with respect to x, because we assumed log x as x in our mind. Understood this part, my children? Right. Because d by dx of cos x is equal to minus sin x, and d by dx of sin x is equal to cos x, and we used chain rule. By using this formula and chain rule, we got this step. Understood this step, my dear children? Right. This implies dy by dx is equal to minus 3 sin of log x into 1 by x, because d by dx of log x value is 1 by x. Understood this part, my dear children? Right. Come to the second term, plus 4 cos of log x into here also d by dx of log x value is 1 by x. Understood this term also, my dear children? Right. Because d by dx of log x is equal to 1 by x. By using this formula, we got this step. Understood this step, my dear children? Right. This implies dy by dx is equal to, by simplifying the first term, what will you get? Minus 3 sin of log x by x. And by simplifying the second term, what will you get? Plus 4 cos of log x by x. Understood this second term, my dear children? Understood this step, my dear children? Right. This implies we wrote LHS as is dy by dx is equal to, if you observe this RHS, they are in the form of sum of two fractions. So we take LCM of the denominators. So let us take LCM of the denominators. What are the denominators here? X, x. So LCM of these two is x only. Understood this LCM of the denominators, my dear children? Right. Now come to the numerator part. We get in the numerator minus 3 sin of log x plus 4 cos of log x. Understood this numerator part, my dear children? Right. Now we take the cross multiplication. So we send this x to LHS. This implies what will you get? X into dy by dx is equal to minus 3 sin of log x plus 4 cos of log x. Just we have sent this x to LHS. Then we got this term in LHS. Then we write the numerator part as it is here. Understood this step, my children? Right. Now differentiating with respect to x. Again we are differentiating with respect to x. Then what is the differential operator? Yes, d by dx. So I wrote the differential operator on both sides. This implies d by dx of x dy by dx is equal to d by dx of, I wrote this entire function as it is in the brackets. Understood this step, my dear children? Right. This implies x into d by dx of dy by dx plus dy by dx into d by dx of x. In LHS, we applied the formula d by dx of uv. In LHS, it is in the form of d by dx of uv, product rule. What is the product rule? U into d by dx of v plus v into d by dx of u. Okay, my children? Here u means x and v means dy by dx. Understood this LHS part, my children? By using this formula, we wrote LHS part. Understood LHS, my children? Right. Is equal to minus 3 into d by dx of sin of log x plus 4 d by dx of cos of log x. Directly I wrote numerical coefficients before the differential operator, and I took the differentiations of the two terms separately. Understood this RHS part, my children? Right. So by using this product rule, we got LHS part and we wrote the RHS. Understood this step, my children? Right. This implies x into d by dx of dy by dx. What is the value of d by dx of dy by dx? Yes, d square y by dx square. Understood this first term, my children? Right. Plus dy by dx into d by dx of x. What is the value of d by dx of x? Right, 1. Understood this second term, my children, in LHS? Right. That is equal to, come to RHS, minus 3 into, it is in the form of d by dx of sin x. We have to use here chain rule because it is not in the standard form. It is not the standard derivative. So we assume that log x is equal to x in your mind. So it is in the form of d by dx of sin x. What is the formula? D by dx of sin x. cos x. So cos x means log x only. Understood this part, my dear children? Right, into d by dx of log x, because we assumed here log x as x in our mind. So I wrote this part. Understood this first term, my dear children? Right, now come to the second term, 4 into, again it is also not in the standard form. It is not a standard derivative. D by dx of cos x, it is in the form of d by dx of cos x. We assume that log x as x in our mind. So it is in the form of d by dx of cos x. What is the formula? D by dx of cos x minus sin x. So minus sin x means here log x. We assumed here log x as x. Understood this part, my children? Right, into d by dx of log x. Whatever the function is assumed as x, we have to differentiate again here. This is a chain rule. Understood this RHS part, my children? Right. This implies x into d square y by dx square plus dy by dx. I wrote LHS. Understood this LHS, my children? Right. Is equal to, come to RHS. What is the value of d by dx of log x? 1 by x. So by simplifying this term, we get the first term as minus 3 cos of log x by x. Understood this first term, my dear children? Right. Now come to second term. What will you get the sign? Minus, plus into minus, minus 4 sin of log x. What is the value of d by dx of log x? 1 by x. So we wrote as a denominator by x. Understood this second term, my dear children? Right. This implies x into d square y by dx square plus dy by dx is equal to, here also we take LCM for the denominators. What is the LCM of the denominators? X only. Then what will you get in the numerator? Minus 3 cos of log x minus 4 sin of log x. Understood numerator part, my dear children? Right. This implies x into x d square y by dx square plus dy by dx. We have taken cross multiplication, so we have brought x to this LHS. Understood this LHS part, my children? Right, is equal to, what will be left in the RHS? Minus of, I have taken minus common factor from the two terms, then we get this RHS. Minus of 3 cos of log x plus 4 sin of log x. Understood this RHS part, my children? Right. This implies here we use distributive property. So x into x, what will you get? X square d square y by dx square plus x into dy by dx. Understood these two terms in LHS, my dear children? Right. Is equal to minus, if you observe this entire function, it is nothing but given function y. From the equation 1, we can write its value is y. Understood this RHS part, my dear children? Understood this step, my dear children? Right. This implies x square d square y by dx square plus x dy by dx. We are bringing minus y to LHS. Then it becomes plus y is equal to 0. Understood this step, my dear children? Right. This implies x square y2 plus x y1 plus y is equal to 0. Because d square y by dx square can be written as y2. And dy by dx can be written as y1. Do you remember this one, my dear children? At the beginning, in the concepts we have discussed. These are different notations. Okay, my dear children? So we can denote this by y2. Dy by dx can be denoted by y1. Understood this step, my dear children? Right. This is nothing but a required statement. So hence proved. Understood, my dear children? Right.